Hi again, boys and girls. Okay, so today we're going to talk about scatter plots in something called trend lines. Last week you guys did scatter plots, and we talked about how that was just a graph with all the points of data on it. We talked about how it has a positive association, a negative association, whether it is strong or weak association, whether it's linear or non-linear, right? You were also introduced to the word cluster, which meant when all your data is kind of clustered in one spot. You may have a couple of clusters on a graph. You were also introduced to the word outlier. Outlier was in your work. It was also on your Mathia lesson. And outlier is when you have that point of data that's away from all the other data. It's kind of hanging out by itself. Okay? So today we're going to talk about scatter plots again. We're going to look at some, and we're going to talk about trend lines. And you see that all of these little graphs here have lines drawn through them with arrows. And so we're going to find the equations of trend lines, and we're going to use slope and y-intercept, so y equals mx plus b form, to find that. And we're still going to talk a little bit about whether the data is positive, negative, what the data actually means. Okay? All right, so let's take a few notes to get started. When we start right here, when scatter plots demonstrate a linear relationship, a straight line can be used to show the general pattern of a data. Okay, so we talked about that the other day. When it's linear, we can see that it's kind of, it's kind of clustered together where it's going in one direction, but it's all kind of, we call it a strong association, right? It's kind of tight. And it's also, you can see it's going in a straight line. It doesn't have that curve to it, right? So we talk about linear. A trend line, or what we're going to start calling it, is a line of best fit, is a straight line that should lie as close as possible to the points of data in the scatter plot. Now, it's going to lie as close as possible to the points in the scatter plot, but it does not necessarily have to pass through the points of a scatter plot. Okay, and there may be sometimes where it does, but there may be sometimes where it doesn't actually pass through any points at all. You're looking to maybe have about the exact same number of points, not exactly, but you're looking to have the same number of points above and below that trend line. Okay, so you're trying to making sure it's going right through the middle. All right, for these four examples, we're going to tell whether yes or no to describe whether or not the line is a good trend line. So when we look at the data here, we look at all these data points, what do we notice? We notice that they all go in a positive direction, right? They're close, but they all go in a positive direction. Now here is a line drawn, and this is a trend line. Is that trend line going as close as possible to all the points in the data? Right, the answer is no. Okay, so the answer here is no. And we can say here that the scatter plot is positive, right? They all go in a positive direction. So the scatter plot is positive, but the trend line is negative, right? It goes down from left to right. Okay, you can always stop or pause this anytime you need to. So now let's look at number 2. Is the line a good trend line? So let's look at our data. All of our data is in linear form, right? And it's going in a negative direction, fairly close together. Now you notice there's also a line going right through the middle of that data. Do you see how there's about the same number of dots above the line as there is below the line? Okay, so that's a really good trend line. So we're going to say, yes, this is a good trend line. and the trend line lies close to the data point. The data points, okay? Okay, sorry if you heard some of that noise. I had one of my boys was coming in here. All right, let's look at number 3. Number 3 also has a lot of data, right? And that data is moving in a negative direction because it's going down from left to right. We see a trend line as well. And we notice that trend line is also going in a negative direction, right? It's going down from left to right. However, does that trend line go through most of the data? Right? No, it goes through exactly 1, maybe 2 points, but it doesn't go right through the middle of that data. It's not cutting that data in half. So we're going to say, no, this is not a good trend line. The trend line is actually above most of the data. Okay, so if I were going to draw a trend line here, my trend line would want to come more towards the middle of here, right? That would be a better trend line. Okay, and now let's look at number 4. Again, we see all of this really tight, really nice. It's going in a positive direction because it's going up from left to right. We also see the trend line is a positive trend line going up from left to right. However, is it a good trend line? Is it going through the middle of the data? That's right. The answer is no. The trend line is below most of the data. Okay. So again, to talk about that, whenever we're looking for a good trend line, we're looking for a trend line that goes through the middle of the data. We want to have about as much data above the line as we do below the line. So it should cut through right through the middle. Okay. It doesn't have to go through points exactly. So there doesn't have to actually be any points on the line at all. But we want to make sure that it's kind of cutting it in half, cutting it through the middle. Okay, so now we're going to talk about how to rewrite the equation for trend lines. It's just like we write an equation for any line on a graph, right? We're going to look for the slope, we're going to look for the y-intercept, and we're going to use those to write an equation in y equals mx plus b form. Okay, that's something we're all familiar with. So we're going to put here, we're going to put y equals mx plus b. We're going to write down some things to remind us of stuff. M is slope, right? That's your change in y over your change in x, or rise over run. Okay, we also have rise over run. And then b is your y-intercept. Remember, that's where it crosses the y-axis. Okay? All right. Now, just like we've been working on, you guys have worked on this a lot, we're going to find 2 points. We can look at the rise over the run, or we could actually use y2 minus y1, x2 minus x1, okay? We could actually use that as well. All right, so we're going to choose any 2 points on a trend line and set up a ratio of rise over run to find the slope of the line, or m. Remember that slope is equal to m. Then we're going to look at the y-axis to find the y-intercept of the line, or b in our equation, right? use these two to write an equation in slope-intercept form. So we know that y equals mx plus b. Okay? All right. Now we're going to write an equation. So for these, we have 5, 6, and 7. I want us to find b, which is the y-intercept, and then we need to find m. And when we find m, I know this has been a question I've received on email and stuff like that. It's not necessarily wrong to put m in decimal form, but more often than not on our test, you're going to find it in fraction form, in simplest fraction form. So whenever you get your fraction, you're going to want to leave it as a fraction, but you want to make sure that you simplify it as low as it can go. Okay? We will check, though, on certain things to see if that's equivalent. But just whenever you're doing slope, try to think of it as rise over run, so you want those two numbers, okay? You want the top number and the bottom number, your numerator, your denominator, your rise over your run. Okay, so leave it in fraction form, but simplify it in fraction form. All right, my b. I always start with my y-intercept because it's always the easiest. I can find it. My y-intercept is right here, right? So if you can't see that, my y-intercept, I'm try to zoom in a little bit. My y-intercept is at 8, okay? So it's a 0 and 8, but I'm just gonna put 8, okay? This is 0 and 8 if you want to put that there. All right, now my slope. I can use this y-intercept right here at 8, and if I find another point on the line, now I don't have to actually find a point on the line. I can make one, correct? So when I see that it crosses at an intersection, like right here, I can make my own point if I need to, and make my little triangle that goes across. Your rise, up and down, over your run. Now look at your scales. They're both counting by 1, so we're okay, right? So we went down 1, and we went over 1, 2, 3. Now you notice I said down. If you look, what kind of line do we have here? What kind of slope do we have? What kind of association do we have? We have a negative association, so our slope is going to be negative, and it's a negative 1 over 3. So when I write that into y equals mx plus b form, I have y equals negative 1/3 x plus 8. That is the equation of my trend line. Okay? Now, if you don't have this negative, boys and girls, it's wrong. So make sure we have this if it's a negative slope. Now, if it's positive, I don't have to put a positive sign. We just assume and understand that it's positive if there's no sign at all. But if it's negative, you have to have that negative sign. And remember, if we're going down from left to right, we're always negative. Okay? Let's look at number 6. So on number 6, I'm going to put my y-intercept and I'm going to put my slope. And I'm going to go ahead and look. My slope is going to be going up from left to right, so I know it's positive. I'm just writing that there to remind myself, okay? I'm not going to use it really, but I'm going to remind myself of that. Now, my y-intercept. Again, here's my x-axis. Here's my y-axis. Right there's my y-intercept. So my y-intercept is 100. Okay, because this point is 0 and 100. Okay, now that's my first point. I'm going to use that point, and I'm going to find another point where it crosses. I'm going to put right here. Remember, there doesn't have to be a point there. I can make one, and I'm going to go up and over. Up, rise, and run. Okay? Now I'm going to look at my scale. When I go vertically, my change in y, you notice they're counting by 50s, but not every block is 50. So from here, they skip a block and then they have 50. So this block in between is 25. So every block is worth 25. So if I have 0, 25, 50, that makes this one 75. 100, 125, 150. Okay? So now I'm looking. I rose from here to here. I went from 100 to 50. So how much did I rise? Right? Good. My rise was 50. Now, when I look on my run, my x-axis is counting by 1. So I'm okay to count each block by 1. So 1, 2, 3, 4. I have 50 over 4. Okay? So I'm going to come over here, and on my slope, I have 50 over 4. Now, you can actually put that in Desmos, okay? And when you put that in Desmos, it's going to give you a decimal number. However, give me 1 second as I'm logging into my computer over here too, and I'm going to see if I want to make sure I'm telling you right. Remember, in Desmos, we're always using testing Desmos now, right? We want to make sure that we are practicing like we're going to have to play, right? So, I want a graphing calculator. Okay, so if I put in 50 over 4, it's going to give me 12.5. But we had that conversation about leaving it in fraction form, right? If you hit the two little squares over on the left-hand side of your problem, it will actually simplify that for you, okay? So it simplifies by dividing each one by 2 and makes it 25 over 2. Okay, so here is my slope. So my equation is y equals 25 over 2x plus 100. Y equals mx plus b. Okay, so y equals 25 over 2x plus 100. We're just writing the equations of those lines, just like we normally would, like we have in the past, okay? There's nothing different about them. All right, let's look at number 7. On number 7, I want to know my b, and I want to know my m. What do I notice about my slope? That's right, from left to right, it's going down, so it's a negative slope. I'm going to put that negative there so I don't forget, okay? Even as a teacher, I forget to put the negative sometimes, so I'm doing this to remind myself. All right, y-intercept is right here. So it's a block in between 40 and 50. I can assume that this would be 45. And so my y-intercept is 45. Okay. Now my slope, we said it's negative. And I'm going to have one here at 45, and it looks like I can make another one right here. So I'm going to go down and over. Rise and run. Okay, so on my rise, on my y-axis, what do I notice they're counting by? The numbers are by tens, but they're skipping a block. So each block or each line is worth 5. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? So my rise is going from 45 to 35. So I'm going down by 10, right? So there's my negative 10 over. And if you look at the x-axis, I'm counting by ones, and it's just moving by 1. So negative 10 over 1. Now, I can simplify this and say negative 10. I can also leave it as negative 10 over 1. Okay? Either way. All right, y equals negative 10x plus 45. Remember, I said you could leave it, so y equals negative 10 over 1x plus 45. Okay? All right, so that should kind of be a little review pushed into some of our new stuff. Okay? All right, let's look at the problems here on the back. All right, to find the slope of the trend line below, Riley chooses the points 180 and 2 and 30. 1 and 80 and 2 and 30. So I'm going to find those points real quick. 1 and 80, so right here, and 2 and 30, so right here. So here are the 2 points he's talking about. Let me see, you can kind of see my blue over them. Explain whether the points she chooses will help her write the correct equation of the line. So if she's writing the equation of the line, would I use those 2 points to write the equation of the line? Think about what we use. If we use points that were on the line or off the line? On the line, right? So no. The points of data are not on the trend line. Okay, so those aren't good points to use to find the equation of the trend line. Okay. Remember over here when I was finding the equation of the trend line, I had to make my own points, right? There weren't necessarily points where I was going, but those points were on the actual line. Okay? So when we come back over here, we're going to go ahead and write the equation of this line. So we're going to find our M and our B. Now, our M, our slope, is going down from left to right. So I know it's negative, so I'm going to go ahead and put that negative sign there so I know. My B, my y-intercept, is right here. So it's at 90. Okay? Now, I can use this point because that point is actually on the line. Yes? And I just need to go down and find another point that's going to be on the line. I'm going to use this one right here. If you choose points that are closer together, the less you're going to have to simplify your slope. Now, I could use this point and this point all the way down here. Okay, and I could make me a big triangle. And I wouldn't be wrong. I would just have to simplify more. So the closer my dots are together, the less I actually have to simplify. Okay? So I'm going to rise, I'm going to go down and over. Rise, over, run. Rise, over, run. All right. If you notice, I'm going to kind of zoom in for you here. If you notice, what are they counting by on this scale? Okay. They're counting every line, and every line increases by 10. Yes? So she's going from 90 to 70. So she's decreasing by 20. Okay? And then the run, if you notice on the bottom, your x-axis, they are just counting by ones. So this is just a jump of 1, so 1 is going to go on the bottom. Okay, and remember, I can simplify that to just negative 20, or I can leave it as negative 20 over 1 in fraction form. Either would be correct in this case. Okay? All right, so to write the equation of my line, I'm going to use the information I just found. And y equals negative 20 over 1 x, because mx, right? Plus the b, and the b in this case is 90. Okay? All right, number 9. Here's another example. Which of the following scatter plots could have a trend line of y equals 2x plus 5? Okay? So first of all, here's what I'm going to look at. I'm going to look at my slope. Is my slope positive or negative? Positive or negative? My slope is positive, right? It's just a 2x. There's no negative sign there. So I look at this first one. I've got a negative association. So I know that's not an option. I also look at D. What do I notice? A negative association. I know that's not an answer. So I've eliminated 2 and I'm down to just 2 choices. Okay? Now, I'm going to look at my y-intercept. My y-intercept is at 5. If I were to draw a line through the middle of these data. Which one of these lines would start approximately at 5? Which one would you assume? Right, C, right? I could say this would be about 5 because we know this one right here looks like it's 0, 0, or the origin, right? It looks like that's a proportional relationship there. Okay, so explain my choice. The line starts above 0 and has a positive slope. Okay? The line starts above 0 and has a positive slope. Remember, you can pause or stop this video at any point. All right. Mrs. Hamilton surveyed some of her students by asking how many minutes they spent studying for their math test and the score. They made on their math test. The results are shown below. So we notice that we have people all over the place here. Let me kind of zoom into this graph a little bit. We see that the more they studied, the higher their test grade went. We did have a little anomaly here. If you look at it, he only studied for 5 minutes, but he made a 100 on the test. Maybe a 99. Okay? So we're going to talk about what is the slope of the trend line. So what is our slope? Well, I'm going to pick a point here, and I'm going to pick this point here. I know our slope is positive, right? Okay, so I'm going to rise, and I'm going to run. Rise, run. I notice that my y-axis is counting by tens, and every line is worth 10. So I went up from 60 to 70. So I had a rise of 10. Okay? Over. Now, if you notice on the x-axis, they're counting by 5s. So every line is worth 5. So we're going 5, 10, 15. So 10 over 15. Now remember, I told you you could put that into Desmos, and Desmos would simplify that for you, actually. Okay? But what number would divide 5 and 15? 5, that's right. Okay? So if I divide them both by 5, I'm going to get 2 over 3. So my slope is a positive 2/3. Okay? What does the slope mean for the context of this problem? So that means that this is the rise, right? So it went up by 2 for every 3. So that means that for the test scores increased by 2 points for every 3 minutes of study time. Okay. All right, the next question. What is the y-intercept of the trend line? So where does the trend line start? Where does it cross the y-axis? So here's my y-axis. The line starts right here at 60. So my y-intercept, my b, is 60. And what does the y-intercept mean in the context of the situation? Okay, so if I have 0 and 60, that means that if someone studied for 0 minutes, they would have scored a 60. So a student (0 minutes) scored a 60. And then we're going to write the equation of the line. Remember that y-intercept is my b, right? And that slope is my m. Okay, so y equals mx plus b. Y equals, my m is 2/3. So 2/3 x plus my b is 60. Okay, so all we did today was look at scatterplots, talked about what we remembered about scatterplots, positive, negative associations, and then we drew a line of best fit or a trend line through that data. And we talked about how that trend line needs to go straight through the data, ideally having as many dots above as it does below the line. It does not have to go through points of data. It can, but it does not have to. And to write the slope of that trend line or the line of best fit, we write it just like we write the equation for any other line. We find the slope, we find the y-intercept, and we write the equation in y equals mx plus b form. Okay? All right.